My screen is visible to you. Wasim sir, hello. Hello. Deepak sir, hello.
Yes,
Hello.
we can
Yes,
see.
Yeah,
yes.
screen is visible, na?
Yes,
Yeah.
Okay, okay, okay. This is the live class of week 11. Uh, Now we have already entered into the hydrogen safety. Okay. Before coming to that part, we'll discuss the the uses of the hydrogen as a fuel in a combustion engine, and then we'll gradually go ahead in the safety further. Okay. Okay. First questions: whether hydrogen can be used in IC engine or not, directly in IC engine or not. Whether hydrogen can be used, can hydrogen be used in combustion engine? If yes, please explain. If not, then also explain. This is the basic questions suddenly may knock in your mind or may knock someone else or everybody. I discussed about the hydrogen as a fuel in IC engine. Actually, the hydrogen as a fuel directly uses in the IC engine or combustion engine. It is not effectively used or effectively utilizations of the hydrogen as a fuel, because if we use hydrogen in a combustion engine, the hydrogen will be combustible form, and it will produce water, it will produce H2 and different combustion gases. But there is no NOx, COX, because it is not it is not like hydrocarbon. Okay. Can you please mute yourself? Okay, thank you. Hydrogen cannot be used directly into the combustion engine because the efficiency of hydrogen combustion engine is very less. So why we will call hydrogen as a fuel? But if we use the hydrogen in another way, like associating one fuel cell will produce electricity, and then this electricity will be used for running out the vehicle. Then it is the efficiency will be high. Near the efficiency will be as above 70% or 80%. But if the hydrogen will be used in the combustion engine, the efficiency is very very less, below 20%. Okay, that's why it is not a good way of uses hydrogen as a fuel directly into the combustion engine or directly into the combustion chamber. Okay, so what are the advantages and disadvantages if we uses the hydrogen in the IC engine, or which IC engine will be at least good or better for hydrogen combustions in the combustion chamber? Okay, there are two types of IC engine. One is the petrol engine and another one is the diesel engine. Okay, petrol engine is called petrol engine, diesel engine. Petrol engine is called spark ignition engine. Okay, or this is called compression CI engine or compression engine. This is SI engine, spark ignition engine, and this is CI engine. Petrol engine is called spark ignition engine because that one spark plug is used to burn the fuel, to burn the petrol. That's why its name is the spark ignition engine. And for the diesel engine, compression ignition engine means that the gases will be compressed and the high temperature will be generated, and due to this high temperature the fuel will be burned. Okay, this is the diesel engine. Okay, generally petrol engine has a smaller size smaller size, but diesel engine, it is generally comparatively larger. Okay, generally in CI engine the flywheel will be act as a energy storage, and there is no flywheel in the petrol engine or SI engine. Okay, this is the basic about the petrol engine and diesel engine. So now we'll go into details whether the hydrogen can be used in place of petrol or diesel, and which one will be more suitable. Okay, in which engine the hydrogen may be used. Okay, uh, before that, before that, coming to the flammability, you should know the some property of the hydrogen associated with the combustion, like flammability limits. Okay, flammability limits means that air fuel ratio, very high air fuel ratio, that means fuel is very very less and air is very high, that means lean fuel, it is called lean fuel. Okay, hydrogen has a very high tendency of catching fire, or flammability limit is very very high. Okay, so even if a small amount of the hydrogen will be present, the flammability, the flammable, it can be flammable. Okay, that's why it is the high flammability limits. Okay, or you can say, like, in the next slide, the drawing is there, I will discuss on students is waiting. Okay, that's good. This is the flammability limits. And next I am coming to auto ignitions. This terminology is very, very important. Uh, Auto ignitions. Auto ignitions, why the auto ignitions is important for IC engine? For each case, auto ignition temperature is important for the petrol engine as well as diesel engine. Okay. Suppose auto ignition temperature, if the auto ignition temperature is low, that means it is better for compression ignition engine, I mean diesel engine. And if the auto ignition temperature is high, then it is better fuel for the petrol engine or SI engine. Okay. So you can remember the auto ignition temperature of hydrogen is 500 degrees centigrade. It is very, very high. Okay. Whereas petrol has a auto ignition temperature 245 to 280 degrees centigrade, and 200 degrees centigrade or 210 degrees centigrade for the diesel engine. Okay. Why this auto ignition temperature is important? Just you need to understand uh, why this auto ignition temperature. Auto ignition temperature. Ignition temperature. As the name suggests that the fuel will be automatically ignite. How the automatically ignite? How the automatically ignite? Suppose you have one fuel. Suppose you have petrol. Okay. Suppose you have petrol. This is the one fuel. The how the ignition auto it will be auto ignited. If we increase the temperature of the petrol, if we increase the temperature of the petrol, then at a certain temperature, suppose at petrol, for the case of the petrol, 280 degrees centigrade, 280 degrees centigrade, when the temperature of 280 degrees centigrade will reach, the petrol will automatically ignite. You do not need any supply of any external fire. Okay. This petrol will automatically ignited. Okay. At which point the petrol will automatically ignited, at which temperature, this is called auto ignition temperature. Similarly, the diesel has auto ignition temperature. It is interesting that diesel has diesel has auto ignition temperature lower than the petrol. It is around 200 degrees centigrade. Okay. If the temperature of the diesel reaches 200 degrees centigrade, the diesel will catch fire automatically. Okay. This is called auto ignition temperature. Okay. And whereas hydrogen has auto ignition temperature around about 500 degrees centigrade. Because do you know why the hydrogen has very high flammability limits? High flammable. Hydrogen is a very high flammable gas. But auto ignition temperature is very, very high. I mean, after reaching a very high temperature, it will ignite, or it will burn, or it will start firing, or it will catch firing. Why? Because you know that hydrogen molecules has lower density. Okay. The molecule between the two molecules, the gap between the two molecules is very, very large in distance. Okay. Then what will happen? The collision between the when the temperature, just wait, someone is waiting. Huh. Why the hydrogen has a higher autoignition temperature? You know, the density of the hydrogen is very, very less. So the two molecule, the gap between the two hydrogen molecule is very, very high. When the temperature will be given, how it is automatically ignited? When the temperature is provided into the hydrogen, the randomness of the hydrogen gas molecules will be high and the collisions between the two molecules will be less because the distance between the two molecules is very, very high. What is the inner meaning of the autoignitions or ignitions? When the two molecules will be collided each other in a random motion, the collisions, due to the collisions, the frictions force will be generated. Due to the frictions, high kinetic energy will be generated, or due to the high kinetic energy, the energy will be released, and at some level, it will automatically ignite it. As the hydrogen gas molecule has a very large distance, the collisions and the frictions will be less. Okay, that's why the autoignition temperature of the hydrogen is very, very high. So you have to reach 500 degrees centigrade, then hydrogen will catch fire automatically. Whereas petrol or diesel at 200 degrees centigrade, it will catch fire. This temperature is called the autoignition temperature. Okay. And what is the flammability? Flammability means that high flammability. Hydrogen has a very high flammability. Suppose uh, what is discussed, Sandeep sir, what has discussed for the in the kitchen room, there is gas oven. Okay. LPG gas oven. Okay. LPG gas oven. When the gas knob is open, the fire will it will fire. Okay. And it will restricted within a certain zone. It is restricted within a certain zone. Okay. For the LPG. But for the case of the hydrogen, for the case of the hydrogen, as the diffusivity of the hydrogen is very, very high. Okay. The diffusivity for the hydrogen fuel, the flammability is very, very larger area because and heat transfer coefficient is very, very high. So it will reach, the fire will reach, or fire will take maximum area or a larger distance compared to the LPG gas. Okay. The distance from the gas outlet of fire, the fire distance is very, very high for the hydrogen compared to the LPG. This is called the flammability limits. For the case of the hydrogen, the flammability limits is very, very high. Okay. And as you know that due to the combustions with the atmospheric air nitrogen, it will produces carbon dioxide, and NOx and SOx, different, and soot particle also. Okay. This is all about the autoignition temperature as well as the flammability limits. Okay. Uh, Flammability limits. Reactivity of the fuel. The reactivity fuel of the hydrogen fuel is very, very high compared to the LPG or petrol diesel. That's why the flammability is high. Okay. And ignition temperature is also required, and the thermal conductivity is very, very high for the hydrogen fuel, when the thermal conductivity of the hydrogen fuel is very, very high, the, at the far distance, at the longer distance, the hydrogen, the presence of the hydrogen gas molecules will have at higher temperature, because the conductivity of the hydrogen is very, very high. So the temperature is very high at a certain distance, or at a larger distance. Okay. So the flammability will be very high for the hydrogen. Okay. And one more important things is the this terminology is very, very important. That's why I am discussing it deeply. Flame front propagation. Flame front propagation. That means, suppose this is flame front is propagating like a wave. Okay, the flame is propagating like a wave. Okay, this is called flame front propagations. How fast the flame is propagating? Obviously the hydrogen has a very high diffusivity or lower density, so it will travel faster than the petrol and diesel. So flame front propagations of hydrogen is very, very high. Okay, this is, you can take it as a advantages, but for the case of IC engine, it causes some disadvantages. How it causes disadvantages? The disadvantages is like that. Suppose at a constant engine speed, the rate of, or the flame propagations rate is very, if the flame propagations rate is very high, then what will happen if the flame front propagations is up to the bottom dead center? This is bottom dead center, and this is top dead center. If the flame front propagations is quickly completed up to the bottom dead center, your, before the completing one cycle, or before completing one power stroke, the flame, the second flame is already traveled or already propagated up to the bottom dead center. Then what will happen? Then the extra energy will be released, and this extra energy and high pressure and high pressure after burning the hydrogen, high pressure and high temperature will be created inside the combustion chamber. Due to the high pressure and high temperature, one knocking will be there. Or knocking means, what is knocking? What is knocking? Knocking is, knocking is creating some high pressure, high temperature inside the combustion chamber, and this high pressure, high temperature, it will vibrate the engine. Okay, with a very high sound or large sound. Sometimes your engine may sound very high. That means the knocking is there, the unnecessary combustions is happening inside the chamber or your vehicle, and your vehicle is vibrating very largely. This is called knocking. Knocking is generally happen due to the faster self propagations or faster flame front propagations. Okay, this is important. So for reducing the knocking, you have to match the vehicle speed or flame propagation speed. Okay, suppose at a certain RPM, you have to match the certain RPM. According to that, the flame propagations rate should be determined. Okay, these are the all the things whatever I discussed, and the basic principle of the SI engine and CI engine. Again, I am just telling you, explaining. This is the SI engine. This is the spark ignition engine, or you can say petrol engine, and this is called diesel engine. This is compression ignition engine. The working principle of the SI engine and CI engine is different. Coming to the SI engine, what will happen in a combustion chamber or cylinder? This is piston cylinder. What is this is cylinder? This is cylinder and this is piston. Piston is moving top dead center TDC and moving downward directions bottom dead center BDC. Okay. When the pistons goes down up to the bottom dead center, what happen? The air fuel mixture means air and petrol mixture will come to the combustion chamber. Okay, and then the next step, there is one spark plug. This is called spark plug. This spark plug will ignite, will help to catch fire in the fuel air mixture, and the combustion cycle will start. When the combustion cycle will start, then some energy will be liberated. This energy will help to move this piston from top dead center to bottom dead center, and simultaneous cycle will go on. For the case of the CI engine, it is something different. What will happen here? Here in the combustion chamber, this is combustion chamber. This is combustion chamber or cylinder, and this is piston. Piston is connected to the crankshaft and connecting rod. This is crank. This is connecting rod. And this is crankshaft. Here is the crankshaft. What will happen in the case of the petrol engine? Generally, for your bike is petrol engine. Okay, some four wheeler is also petrol engine, and as well as some diesel engine also. Okay, for the case of the compression engine, at first the air will drawn into the combustion chamber, and the piston will compress this air, means that the piston will goes top dead center, and it will compress the air. And during the compressions, if the compressions will be there, or mean pressure is high, obviously the temperature goes high. Okay, and this temperature will reach up to 200 degrees centigrade. Up to 200 degrees centigrade. When the 200 degrees centigrade temperature will reach, there is one nozzle or fuel injector. This is called nozzle or fuel injector. Okay, the fuel injector, what is the function of the fuel injector? The function of the fuel injector is to atomize the fuel. Atomize, atomize, AUTO, atomize. Atomize the fuel. Atomize the fuel means it will create, or it will produce the fuel into very smaller particle. Okay, such that the combustion will be uniform combustions. Okay, and when the fuel is spread, I mean diesel is spread into the high temperature combustion chamber at 200 degrees centigrade, we know that the auto ignition temperature of the diesel is 200 degrees centigrade. It automatically catches fire. So the combustions will occur inside the combustion chamber of the diesel engine or compression ignition engine. Why it is called compression ignition engine? because the air will be compressed. That's why it is called compression ignition engine. Then after compressions, the temperature will reach at around 200 degrees centigrade. Then the fuel will be burning with the help of the air. This is called the compression ignition engine. Okay. Now questions is that hydrogen can hydrogen be used in SI engine, or hydrogen will be used, the use of hydrogen for the CI engine is comparatively good, but it is not good. But we will compare in which cases hydrogen can be used, or hydrogen with the fuel mixture, can hydrogen can be mixed with the petrol or diesel or LPG. Okay, in such a way also hydrogen can be used for getting higher calorific value. Okay, so in which cases it is more suitable. Okay, the question is, the hydrogen can be useful for the SI engine. Spark ignition engine is good. The uses of the hydrogen in the spark ignition engine is good than the ignition engine. Compression ignition engine. This is bad. Why? As you know, the auto ignition temperature of the hydrogen is very high. Auto ignition temperature is very high, like 500 degrees centigrade for the hydrogen. Okay, so automatically ignite the hydrogen, we required very high pressure or very high temperature for the case of the compressed ignition engine. In that case, for reaching 500 degrees centigrade, you have to go at a very high pressure. Creating such a high pressure, the design of the cylinder and the pistons is very complex, and the vibrations due to the high pressure will also be very high when we use the hydrogen in the case of the compressed ignition engine. But as the auto ignition temperature of the hydrogen is high, but here what we are doing for the SI engine, spark ignition engine, here we are giving some external agent or external fire by using one spark plug for the case of the SI engine. So we will ignite the hydrogen with the help of the spark plug. So there is no problem of catching fire by raising the pressure or temperature. Here external fire is used to for the combustions of the hydrogen. So hydrogen is good. For the hydrogen can be used in the petrol engine, but hydrogen is not good for the diesel engine. This is all about say that the turbocharging hydrogen can be mixed in the turbocharging. Okay, so higher amount of the calorific value will be generated. Turbocharging means at higher pressures the hydrogen fuel will be injected into the uh, combustion chamber where the turbocharging is used. Most of the racing car they uses the turbocharging because the racing car requires the racing car the racing car requires very high speed at a very limited time. I mean the accelerations will be very high at a very shorter time period. That's why they uses the turbocharging method. I mean the fuel is injected at a high pressure. Okay, this is called turbocharging. Fuel will be used as a high pressure. This is called the turbocharging, or the air fuel mixture will be used as a in as a high pressure or high pressure air fuel mixture will be used in the racing car. Okay. Knocking, already I have discussed the hydrogen. The for the case of the hydro knocking, for the case of the hydrogen is very very high. Okay, and the petrol knocking is very very less. But how we can resolve this problem? We can resolve this knocking by using lean fuel or high amount of the air with a limited amount of the hydrogen. Okay, so if we uses the lean fuel, then this knocking problem can be avoided. Okay. uh, One thing is important. If we uses the hydrogen in the combustion chamber, the as we know the hydrogen has a very high thermal conductivity value. So actually, what is the requirement? The requirement is the inside the combustion chamber, the temperature or reactions should be uniform. Combustion reaction combustion should be uniform combustion, uniform combustions. This is requirement, uniform combustions. But one student is waiting. Inside the combustion chamber, it should be uniform. For getting the uniform combustions, the temperature variations or the temperature should be uniform inside the combustions. The temperature obviously will be high around the nozzle, or for the case of the SI engine, spark ignition engine, the spark plug temperature will be high, but somehow the desired specifications is the temperature will be uniform throughout the combustion chamber. For getting, for the case of the hydrogen, for case of the hydrogen, as the hydrogen has a very high thermal conductivity, high thermal conductivity or high K value, K is very high. So the temperature all around the all over the combustion chamber will be almost same. The change in temperature is very very less throughout the combustion chamber. But for the case of the petrol or diesel, the temperature is very high in that zone. Suppose in that zone 1500 degrees centigrade, but near the wall thickness the temperature is very less. Suppose I mean this is 1000 degrees centigrade. So in that case, the combustions will not be proper or uniform combustions will not be there. So if we uses the hydrogen, this gap or the temperature difference gap or wall thickness or boundary layer will reduce. For the case of the hydrogen, this boundary layer will reduce, it will up to 0.6 mm. For the other fuel like petrol diesel, this boundary layer is very high. So for the case of the hydrogen, there will be uniform combustions throughout the chamber, but by using the other fuel, you cannot get the uniform combustions. This is one advantages of using hydrogen as a combustion. Okay. Next, next NOx emissions. What is happening? The NOx emissions is directly related to temperature. If the temperature will be high, the formations of the NOx will be high. Okay. And the temperature will be less, the NOx formations will be less. It is undesired to form the NOx. We always want that there will be less amount of the NOC release in the atmosphere, or less amount of the hydrocarbon, or less amount of the carbon monoxide or carbon dioxide or any soot particle or carbon soot particle. Okay. For the case of hydrogen, the NOx release or NOx productions is very very less. Why the NOx productions is very very less? Because this is the, it depends on the air fuel mixtures, because the hydrogen can be combustible, because we know that for the case of the hydrogen, lean fuel mixture also can generate power, but for the case of the petrol or diesel, there should be comparatively higher air fuel mixture, or I means that higher fuel or rich mixtures will be used. Rich mixture, rich mixture, rich mixture. For that hydrogen case, it may be lean. That means 0.2. The stoichiometric value is 1. Okay, the stoichiometric value is 1, but lean value is the 0.2. Okay, so for the case of the hydrogen, we can be less or limited, or less amount of the hydrogen can be used, and it can be combustible in the combustion chamber, and the temperature will also be very small, because the less amount of the hydrogen is burning. Okay, so as the temperature will be less, so NOx productions will be less for the hydrogen case, but for the other cases, petrol or diesel cases, the NOx productions will be high, or NOx emissions will be high. And this is one example, or some value you can go through. Next, I am coming to the fuel cell. What is fuel cell? My always the questions is, hydrogen will not be used directly into the combustion chamber. Directly, hydrogen cannot be used into the combustion chamber, because the efficiency of hydrogen, the efficiency of the hydrogen combustion engine is less.
Your screen is not visible. Your screen is not showing.
Acha. Okay, okay,
No, we can see the screen.
okay. Yet, just my, yeah, just who is asking, there is problem, just you can sign out
Yes,
and
yes,
you can
yes, yes, yes. I get it. Get it. Thank you.
okay, when the screen will not visible, just you ask me. Okay, uh, for the case of the fuel cell, huh, for the case of the hydrogen, as the hydrogen cannot be directly used into the combustion chamber, so what are the alternate way to use the hydrogen as a fuel? The alternate way for getting higher efficiency is the fuel cell. The fuel, what does the fuel cell do? The fuel cell will, the input in the fuel cell is the hydrogen and the oxygen, and it will produce the electricity and water as a byproduct. Okay, this electricity can be used to run the motor, and this motor can move your vehicle from one places to another places. In the fuel cell, What is happening in the fuel cell? The chemical energy is converted into electrical energy. How the chemical energy will convert it into electrical energy? It is by the use of the uh, redox reactions. There are two redox reactions. One is the reductions, and another one is the oxidations. Okay, and you know that the in the cathode there is the reductions reactions, and anode is the oxidations reactions. Uh, here what happened? The Here what happened? The hydrogen, the hydrogen is used in the anode side, in the anode side, and oxygen. These reactions, second reactions, is done in the cathode side. Cathode side. I will explain what is happening. Uh, I have to. I need. Okay. This space I can use. What is the fuel cell? The working principle of the fuel cell is like this. There is one membrane or polymer electrolyte membrane or proton exchange membrane. This is proton exchange membrane. Proton exchange membrane means proton exchange membrane. Proton exchange membranes, proton means the H plus. Protons mean H plus. It can selectively transfer.
Is it proton means here? Is it the ion? No.
Proton means no. Proton not mean ion. Here the proton mean ion. You exactly correct. But proton mean there is only one uh, proton. There is no neutron. Okay, clear?
Okay.
That is the proton. Uh, so only proton, one proton is there, no negative charges, electron is not there, so that's why it is in ionic form. So it proton exchange membrane selectively passes the H plus ion from anode to cathode. This is the anode side, this is the anode side, this is the anode side, and this is the cathode side. When the here we will supply the hydrogen. Here I am supplying the hydrogen gases in the anode side. Okay, this is the anode, this is the cathode. Here the I am supplying the hydrogen gases, and in the anode the hydrogen will be oxidized. How the hydrogen will be oxidized? Here the reactions will be like this. H2, the hydrogen gas will be releasing H plus and 2 electron, 2 hydrogen plus, 2 hydrogen plus. Why this is oxidizing reactions? Do you know? This is 11th or 10th, 12th questions.
Anode is negatively charged, so it will repel the electrons.
No. What is the difference between the oxidations and reductions? Simple. When the reactions will be called, this is oxidations, and when this is called reductions. Actually, what happened? The oxidations and reductions both are occur in the question in the reaction. But my question is why the hydrogen is oxidizing here? Mean oxidized because the simple you just understand oxidations mean Oxidations mean releasing electron. Releasing electron. Reductions mean adding electron, adding electron, or in another term, just you mute yourself, please. Uh, Oxidations mean releasing electron, and reductions mean adding electron. Or another term you can say, another word you can say, adding oxygen is also oxidations, and reductions adding hydrogen is reductions. Here, what is happening? Here, the electron is releasing from the hydrogen. That's why here hydrogen is oxidizing. Okay, so oxidations occur at the anode. Okay, so here what happened? This hydrogen H plus ion, this H plus ion will transfer or mitigate or migrate from anode to cathode. The cathode is negative charge. This H plus is attracted. Okay, this H plus is attracted with the electrode, negative electrode, and this H plus will form water with the presence of, here the in the cathode the oxygen gas is supplying here. This oxygens and H plus ion, these reactions, oxygen H plus, H plus, 2H plus, 2H plus plus half O2 is producing H2O. Okay, this reactions is in the cathode reactions. Okay, so what happened? But H plus is migrate from anode to cathode, and the 2 electron is here available. This 2 electron will flow from anode to cathode by the using of the external circuit. 2 electron will flow with the external circuit from the anode to cathode. And if I add one electric bulb and it will glow, that means electrical energy is generating. Okay, so electrical energy is generating from the fuel cell if we supply hydrogen in the anode side and oxygen at the cathode side, the electrical energy will be generated. But it is looking like very simple, not at all, it is very simple. There is a complex method, like complex systems, how the porous, there is a porous transport layer. Okay, this is very important for, there is a porous transport layer, there is a electrode, catalyst on the electrode surface. Okay, this is important. When you will go into details you can study. Okay, uh, here I will say the platinum electrode, platinum noble metal is used for the fuel cell. Okay, both at the anode and the both at the cathode. Here the platinum powder is coated on the porous transport layer, and this porous transport layer is attached with the membrane, and after attaching it is called the MEA, membrane electrode assembly. This membrane electrode assembly is fixed between the two bipolar plate, that means current collector, and this current collector is connected with the external circuit, and this is how the electricity will be generated by using the fuel cell through the chemical reaction. This is the working principle, and you can some advantages and disadvantages you can go through. The major advantages of the fuel cell is there is no harmful gas productions like carbon dioxide or NOx. Okay, and there is only water by as a byproduct, so there is no harmful emissions, and it is very easily be scalable. It is easily scalable. Okay, efficiency is very high than the combustion engine, so more efficient than the combustion engine. Principal operations of a fuel cell, just I have already discussed. And this is the uh, equations for calculating the fuel cell efficiency. That the fuel cell general efficiency, you can use the ideal with the thermal efficiency, thermal efficiency. Okay, this the formula can be used. Type of fuel cell, there are the proton exchange membrane type fuel cell. Here the H plus ion will transfer from anode to cathode. The molten carbonate and the alkaline, here the OH minus. I have to see the molten carbonate, but alkaline for the OH ion will be transferred. And the phosphoric acid, this is also H plus. And solid oxide electrolyte, this is O3 and O2 plus. The reactions is already I discussed for the PEM fuel cell. For the alkaline fuel cell, it is also the reactions will be like this. In the case of the H plus, this OH minus ion will transfer from cathode to anode. Okay, here just opposite. Okay, and for the case of the phosphoric acid, it is also H plus ion will be transferred. Okay, for the molten carbonate, the here the ion will be CO3 2 minus. Okay, solid oxide O2 minus. The solid oxide generally used at a high temperature. It is called high temperature fuel cell. The high temperature fuel cell means like 700 degrees centigrade, 800 degrees centigrade, 800 degrees centigrade. The difference you can study component. There are the different component uses. Polymer electrode membrane, one membrane is required. A catalyst layer is required, like platinum catalyst is used, noble catalyst, iridium catalyst is used. Gas diffusion layer. The gas diffusion layer means the carbon generally used as the carbon paper or carbon cloth. The bipolar plates and gaskets. Some gaskets are used just to prevent the leakage, gas leakage from the systems, from the for getting the uniform gas pressure or uniform gas pressure throughout the electrode surface. There are some irreversibility in the fuel cell. I means there are some losses in the fuel cell. Some losses like activations potential losses and the ohmic potential losses, ohmic over potential losses, and concentrations over potential losses. Activations over potential losses. This is the in the terms of the kinetics. Okay, kinetics of the reactions. Ohmic over potential means that the this is the resistance, ohmic resistance, and concentrations over potential. This is the due to the mass transfer limitations of the higher current density. Mass transfer limitations means that the if the higher number of the ion will be gathered there, this higher number of the ion can accumulated, and there will be a problem for transferring from ions from one place to another places, and this is the concentrations over potential losses. And for the polarization curve, the activations losses uh, is predominant or dominant at the lower current density, and ohmic losses at the moderate current density, and mass transfer losses will occur at the higher current density. At the higher current density, what happen? And the reactions will be very fast. So high number of the ion molecules will gather together, and due to the gathering of the high number of the ions, there will be the it may create some problem. Next is the sensor part. Why the hydrogen sensing is important? Because hydrogen is a very high uh, flammable or very high combustible gases. So there should not there should not be any presence of trace of hydrogen in our work environment, or whether hydrogen is leaking from the chamber or hydrogen is leaking from the hydrogen tank. Okay, so if the hydrogen is leaking from the hydrogen tank, so what will happen that it may catch fire. So the sensing of the hydrogen, or just to make sure the leak of the hydrogen, okay, just the sensors application should be critical. The requirement of the sensor application should be critical. The applications of the hydrogen sensor is useful in the methanol industries, or the hydrations of the hydrocarbon, desulfurizations of petrol product, and different metallurgical processes, or in the steel industry, because for the reductions of the steel, or any steel industry requires the hydrogen for the reductions of the uh, iron ore, or coal mine, semiconductor industry is required hydrogen. Okay, these are the different industry, they uses the hydrogen. So there should be the hydrogen sensor just to detect the whether there will be hydrogen leakage or hydrogen traces in the atmosphere. If the hydrogen traces will be there, it may causes harm. So different sensing method like catalytic sensing method, mechanical, tribological, electrochemical method, and thermal method, and resistive, acoustics, work function based, and optical. And I will discuss one or two. Then I will go for the questions discussions part. First of all, I am coming to the thermal sensor. Thermal sensors. As the name indicates that it is the thermal sensors, means that it will sense the temperature or heat energy. Okay, temperature or heat energy, temperature or heat energy, or heat, or heat. What happened? What happened? Okay, when the temperature will be changed, when the temperature will be changed, this change of temperature will be sensed by thermal sensor. How the thermal sensor will work? When the temperature will be changed, how the temperature will be changed, and it will sense. It will sense by the principle of conductivity principle. Okay, conductivity principle means that the one formula is there like Q, heat transfer rate, equals to Ka dt by dx. This is the heat transfer rate. This is the thermal conductivity of any metal, or thermal conductivity of the gases. Here we will use the gas. This is the surface area, exposed surface area. This is the change of temperature, and this is the length or dimensions. Okay, what happened? This thermal conductivity, this thermal conductivity will be determined at a different change in temperature. Okay, this thermal conductivity will be calculated by changing the different temperature. And at different temperature, when the temperature will be changed, the different thermal conductivity value will come, and according to that value, the prefix value, the sensor will sense that this is the hydrogen gas, the presence of the hydrogen gases. The thermal conductivity of the hydrogen is 0.174 watt per meter Kelvin at 20 degrees centigrade, but air has thermal conductivity is less at 20 degrees centigrade. Here, how the this is changing? This is the reference Wheaton bridge resistance, and this is the working Wheaton bridge resistance. These things you can write as a in terms of resistance. Okay, this is L by K in terms of resistance L by K. This resistance can be measured here, and when the hydrogen, when any trace of trace particle of the hydrogen will be there in vicinity of the working resistance, and this will sense the hydrogen, and the thermal resistance will changes there, and due to the thermal resistance will changes, all other resistance will be fixed, and due to the thermal resistance changes here in this resistance, in this resistor, this voltage will be changed, voltage changes will be there. If the voltage changes will be there, if the higher amount of the hydrogen will be exposed into this area, the voltage changes will be high. The lower concentrations of the hydrogen will be there, the voltage changes will be low. So we can predict that the concentrations of the hydrogen presence in the atmosphere, or you can detect the hydrogen where the hydrogen is leaking or not. Okay, this is the basic principle of the thermal sensor. For the case of the electrochemical sensor, next is the electrochemical sensor. Okay. Uh, Whatever I am discussing, are you getting these points?
Excuse me, uh, I have one doubt. This
Yeah, yeah.
saying thermal conductivity unit is watt per meter Kelvin, right?
Yes, yes.
But at 20 degrees centigrade, what does it mean?
Your voice is not coming clearly.
I am, for example, unit is given something 0.1 something for
Yeah,
hydrogen thermal
yeah,
conductivity watt per meter Kelvin, right?
yeah, yeah.
But at 20 degrees centigrade, why not in the degree should be Kelvin? I'm not able to understand. What is the reason they are different unit?
Okay,
20 degrees centigrade.
okay. This is simple. Just you mute yourself. Just I am explaining you. Suppose 0 degree centigrade. 0 degree centigrade means this is also correct. This is Kelvin. This also you can say centigrade also. This is also you can say centigrade. But there is no difference whether you are writing this is per centigrade or per Kelvin. There is no difference. Just you can understand 0 degree centigrade means 273 Kelvin. 273 degree Kelvin. 30 degree centigrade means
Okay, I understood. 20 degree nothing but
per degree centigrade. Per degree
minus
centigrade or per degree Kelvin. For 1 Kelvin or 1 degree centigrade is the same.
okay,
Okay. For increasing 1 Kelvin, 1 degree Kelvin, or for increasing 1 centigrade, the energy is same. Energy required is same.
okay.
Uh, yeah, Mr. Rathod, I think it is the difference when we do the difference temperature of from say 273 to say
30, 300 degree Kelvin.
so there will be 10K difference. Then
There is
again any 10.
I think yeah, 20 degree is given. It means that means minus 250 minus 253 Kelvin. Talking about at that temperature minus 253 Kelvin.
yes. This is the difference. difference that suppose initial value T1 is suppose 20 degree centigrade and T2 is 30 degree centigrade. 30
Difference is
degrees
always same, correct?
difference
Difference
is
in
always same,
Kelvin and
whether
centigrade will be
whether
same.
it is degree
Correct,
centigrade or it is Kelvin. Per
correct.
degree per degree
Agree,
centigrade or per degree Kelvin is the same.
agree.
Yeah. For the case of the electrochemical sensor, uh, uh, as the drawing is here, just I am not drawing it again. Uh, there is two types of electrochemical sensor. One is the amperometric sensor, and another one is the potentiometric sensor. What the amperometric sensor does at a for the case of the amperometric sensor, the will measure the current. We will measure the current. CURRENT. For the case of the potentiometric sensor, the output value will be voltage or potential or voltage volt. For the case of the output is voltage, here for the amperometric case, it will the a constant voltage will be applied and the current will be measured. Okay, here the potential will be measured, the constant current will be applied. Both are the opposite in nature. There are the three three types of electrode. One is the sensing electrode, and another one is the reference electrode, and another one is the counter electrode. This is called three three electrode system. For the case of the here the for the case of the sensing electrode, there is one diffusion layer. Okay, the function of this diffusion layer is just to diffuse selective gases. Diffuse selective gases means hydrogen. Suppose there is a air mixtures of the hydrogen, oxygen, carbon dioxide, nitrogen. But this diffusion layer, the work of this diffusion layer is to selectively passes hydrogen gases such that it can measure the hydrogen concentrations by using the amperometric relationships or potentiometric conditions. Okay, and this is the next one is the counter electrode, and this is the reference electrode. When the hydrogen gas diffuses into the sensing electrode, it will sense, and suppose for the case of the amperometric conditions, it will sense the hydrogen and the electrochemical reactions will be there. Electrochemical reactions will be there means that at constant applied voltage, suppose I am applying some voltage V0, okay, suppose I am getting some current I0, initial conditions, whether there is no hydrogen, but when the a little concentrations of the hydrogen is exposed or diffuses through the diffusion layer, okay, there will be a voltage changes or voltage will be increased from V0 to V0 plus suppose V1, and the current will also increase as the voltage is increasing. The current will also changes from I0 to I0 plus I1. I mean current will be increased. Okay. So suppose one weight percentage hydrogen, it is the current is increasing I0 to I1. 2 weight percentage for the case of the 2 weight percentage hydrogen, I mean more concentrations of the hydrogen, the current will be increased more, such that if we have some data, we can sense how much concentrations of the hydrogen is there present in the atmosphere. We can sense the amount of the hydrogen or hydrogen concentrations. The for the case of the electrochemical reactions is like that. At the sensing electrode, this is the electron produces, this electron is creating, this flow of electron will producing the current or the voltage difference between the sensing electrode and counter electrode. This is the fundamental uh, working principle of the electrochemical sensor. Basically, the noble material is used like platinum. Okay, platinum is used in the in the sensing. Platinum is coated onto the or on the sensing electrode. Okay, because platinum is has a very high affinity to absorb the hydrogen gas molecule and react, and it will produces the H plus ion or electron. Okay. This is also more or less same working principle, and this is also the same things, but the some structure is different. This is substrate, a heating element, insulating layer, and there are the two electrode, and the things is also here. The concept is the same, but the structure or this is the something different. Work function based sensor. Work function based sensor means that the work function means, what does that mean? Work function means the energy, minimum energy required, the minimum energy required for flow of electrons from metal surface to infinite interface. This is the work functions. On the basis of this work function based principle, there is the sensor. The combinations is like that. There is one semiconductor. There is one semiconductor. This is substrate material, and on the semiconductor, the metal will be deposited. This is metal. This is semiconductor. This is semiconductor, and this is the metal. Okay, this is metal, and one external circuit is attached. Semiconductor and metal surface. What will happen? The hydrogen gas will be absorbed through the metal, and when the hydrogen gas will be absorbed through the metal, and it will go into the interstitials of the metal, and in the interface between the metal and semiconductor, in the interface between the metal and semiconductor, in this place, what will happen? It will create one dipole. One dipole means that the one negative and positive charges, the different charges will be accumulated, the different charges in the accumulated in the metal, and different charges accumulate in the semiconductor. Okay, suppose negative charge will accumulated in the metal or semiconductor, for the positive charge will accumulated. For that case, one voltage will be generated. Suppose V1 voltage will be generated. We can detect this, we can measure this voltage V1. According to this, we can sense the concentrations of the hydrogen presence in the surface or atmosphere. Suppose larger concentrations of the hydrogen is exposed to the metal surface, then the dipole moment or the dipole in between the metal and semiconductor will be higher. So higher voltage will be generated, or higher voltage will be shown or showed in the voltmeter. So we can sense that the high voltage is coming because of high concentrations of the hydrogen. When the low voltage will come, so we can predict that there is the low concentrations of the hydrogen. According to the fixed value of the voltage, we can say the concentrations of the hydrogen present in the atmosphere. This is the way of sensing of hydrogen in the through the working principle of the, by the using of the work functions based hydrogen sensor. Next is the mechanical sensor. How the mechanical sensor work? This mechanical sensor is like a cantilever type. Cantilever means that the one end fixed and another end is free. This is the fixed end and this is the free end. At the free end, what is done? At the free end, palladium coating is there because palladium is very sensitive to the hydrogen. A very thin layer of the palladium coating is done onto the micro cantilever beam, and this micro cantilever beam, when the hydrogen gas will absorb through the palladium coating, what will happen that the hydrogen gas will go inside, penetrate into the palladium material, and it will go inside the interstitials of the palladium coated material, and it will distort the palladium coating or palladium material. It will distort. Distorts means that the high stress is generated or high stress will be originated inside the interstitials of the metal or metal phase or grain boundaries or grain or inside the grain. So when the larger amount of the hydrogen molecules will go inside the palladium coated material, the palladium coated material will expand largely. Okay, then the micro cantilever beam will be bending. Okay, it will bend. When the large amount of the hydrogen will be in the palladium coated, it will feel more stresses, and the micro cantilever beam will also feel more stresses, and this stress can be measured, and when the high amount of the stress will be there, high concentrations of the hydrogen can be sensed. When the micro cantilever beam will be less stresses, so we can say that less amount of the hydrogen will be there. We can detect or we can calculate the deflections of the beam. According to the deflections of the beam, we can sense the concentrations of the hydrogen presence in the atmosphere, or we can sense the presence of the hydrogen. This is called mechanical sensor. Optical sensor, basically it will measures the reflectivity. On the principle of the reflectivity, it will changes the reflectivity, and at the different hydrogen concentrations, the reflectivity will be different value. The reflectivity value will come different, and according to the different reflectivity, we can sense the concentrations of the hydrogen. Okay, I am not going into details because the time is limited. uh, I will share one interesting part, that is, okay, I will go next, but before coming to the part, I have to start the question discussion part. The first questions, is the amperometric sensor uses which technique to sense hydrogen? For the case of the amperometric sensor, the what value will take or what the value will measure, the current value will be measured. Okay, how the current value will be high? When the voltage will be high, when the voltage will be high, when the concentrations of the hydrogen will be high, the voltage value will be high. How the concentrations of the hydrogen? Because the redox reactions will be high, because electron productions will be high, so current will be high, voltage will be high. This is the amperometric sensor working principle. So what is the answer here?
It is C. Diffusion limited current measured at constant applied voltage.
It is the questions number. Answer is the C. Diffusion limited current measure at constant voltage, constant applied voltage. Why this is diffusion limited current measure? Diffusion limited means, why the diffusion limited? Because there is one layer, diffusion layer. It will only permit the diffusion of the hydrogen to the sensing electrode. This is sensing electrode. It will only allow the hydrogen. It will only allow hydrogen to the sensing electrode. It will not allow the oxygen, carbon dioxide, or any other gas present in the atmosphere. Okay, so this is called, because if any other gases like oxygen, carbon dioxide gases will diffuse to the sensing electrode, and it will also the oxidations, the reductions reactions will also there, and electron produce is also there due to the oxygen or carbon dioxide, and the value will not get the proper value. There will be some calibrations. Okay, time to time. So option number C is correct. What is meant work functions? Question number 2. The minimum energy required to remove electron from metal surface to infinite. Maximum energy required to remove the electron from the metal surface to infinite. What is our answer?
Minimum.
Huh.
A.
It is our answer is A. Minimum energy required to remove the electron from metal surface to infinite. Because the work function indicates that the minimum, how much minimum energy. This is actually what happened. You can see that the band gap, a conduction band, valence band. Here what happened, the some energy will be there in form of X-ray, gamma ray, and this band gap, the electron will flow from valence band to conduction band with the help of some minimum energy. These excitations of the valence band and conduction band, the electron will flow, and when the electron will start flowing, that means it started flowing of electron, means the flowing of the current. This is some it is conducting. Okay, this is the basic things. Question number 3. Question number 3. The uncoated silicon micro cantilever type of mechanical sensor uses which method to measure the concentrations of the hydrogen? Change in resonance frequency, change in resistance of sensor, change in electrical conductivity, change in potential. There is no electrical things.
It is change in resonance frequency.
Resonance frequency. Actually, what happened, when the higher amount of the stresses will be generated, high stresses will be generated inside the micro cantilever. High stresses means it will vibrate, it will bend, it will vibrate, it will bend. At high stress. High resonance means what? Resonance means vibrations. Okay, resonance means vibrations, vibrations mean frequency. Okay, so we will measure the frequency. Okay, we will measure the frequency. Okay, how, when the resonance will be there, the resonance frequency is actually, it is the when the it is coincide with the natural frequency, the frequency the coincide with the natural frequency at these situations, it is called resonance. Resonance means it is the combinations of the natural frequency plus working frequency. I means at which frequency,
and the component
frequency. This adding with the natural frequency, the systems will be vibrating at very high frequency level. So this high value we can detect through the frequency level or measure the frequency in hertz. Okay, so at different high hertz, high concentrations of the hydrogen, if it is coming lower hertz, so we can say that the lower concentrations of the hydrogen, the difference, suppose it is 100 hertz is coming, we can say that the 20% weight percentage is hydrogen is present. Okay, a preliminary preset equilibrations is there in the systems, and if the frequency is coming 100, then we can say that the 28% hydrogen is coming. Suppose 50, we can say that the we can say 10 weight percentage hydrogen is there. This is like this way. Next question. Question number 4. Thermoelectric sensor are based on which effect? This is very simple thing. Photoelectric effect, Seebeck effect, Hall effect, and Doppler effect. Thermoelectric sensor,
Seebeck effect. Seebeck
Seebeck
effect.
effect. What is Seebeck effect?
Yes,
Seebeck effect is
if
like
you,
this.
yeah, if in a metal, if you create a temperature difference in both sides,
Hmm,
then there will be I mean, a potential difference also.
hmm.
So I think that is the Seebeck effect.
Exactly. If the temperature difference is there at the two junction, and if we connect the two junction through a conducting device, what will happen? And if we maintain, suppose if we maintain T1 degree centigrade, and if we maintain T2 degree centigrade at another junction, suppose T1 is 10 degree centigrade or 0 degree centigrade, suppose T2 is, sorry, T1 is higher. So suppose T1 is 100 degree centigrade and T2 is 0 degree centigrade or 10 degree centigrade. If I am maintaining by using one ice bath here, I am maintaining one fire, there will be the potential difference. This potential difference can be measured by using this Seebeck effect or this equation. This is called thermoelectric sensor. And if we measure this voltage, if we measure this voltage, we can get the concentrations of the hydrogen. Question number 5. Which method is effective for multi-point sensing of hydrogen using a single device? Using a single device. What answer?
I think optical time domain reflector.
Ha ha ha. ha. Uh, Refractometer means that there is the refractive index. What is the reflective index? Refractive index. Refractive index is the speed of the light in vacuum divided by speed of the light in any object through any object. Okay. This type of meter, if this type of meter is engaged or this type of meter is there, we can get the concentrations of the hydrogen, or we can measure the or we can mate the device. Next question is the nature of the electromagnetic field decay in evanescent field measurement exhibits which behavior? It is, I have written that electromagnetic fields decay exponentially with distance from the surface where they are formed in an evanescent field. This is because evanescent field are non-polar propagating electromagnetic wave. They are spatially concentrated near the sources. What happened? Just I will explain. So our answer is exponential. Our answer is D. So what does that mean? This is interesting thing. Uh, how many students are there? Uh, this is actually interesting thing. Okay. Generally, what happened? Suppose you have one a glass plate. Are you listening? Suppose this is one glass plate. Suppose I am sending one light. I am sending.
Basically, it is prism. Prism.
No. At first, I am taking about one glass plate. Okay. This is one glass plate. Simple glass plate. Yeah. You can also say your windows made of glass. Okay. Like this. If I if I radiate or fall, one light is falling on the glass plate, the light will bend. The light will bend, na? Is it okay? Are you agree with that?
Yes, yes, it will deflect. Yes.
It will deflect. Why? Why it is deflecting, or why the light is bending?
Oh, that forgot.
Refractive. Refractive index.
Yeah,
Because of center
this is
sensitivity of
the
material.
yeah, this is the refractions of light. This is the refraction, not reflection. This is the refraction. This is the refraction. REFREC. Refraction property of the light. What does the refraction property of the light says? The refraction property of the light, that means light, if the light travels through the different medium or different densities of medium, different density of the medium, I think you just okay, mute. If the light passes through different medium at different concentrations medium, the light will be bent. Okay, this is called refraction. The bending of light is called refraction. Okay, refraction, bending of light. This is the bending of light. Here what happened? This is the air medium. This is the air. This is the air. This is the air, and this is the glass medium. This is the glass. This is the glass. GLASS. So concentrations or density of the air is less compared to the glass. So the light will be bent. Okay. This is the refractions. And what is the reflection? When the same light is falling, suppose this is one plane, suppose this is one plane, suppose the first light is incident at a theta 1 angle, and this is coming out with a theta 2 angle. Okay, and again I am increasing the angle. This theta 1 I am increasing. Suppose I am increasing the angle like this way. I am increasing the angle. I have increased this angle theta c. Suppose at a theta c, what will happen? This light will not coming out. The light will not coming out. The light will not coming out. The light will passes through the adjacent layer of the, suppose this is glass medium, this is air medium, through the interface of the glass and the air. If I increase the more theta c angle, what will happen? I am increasing more this angle. This theta 1 angle is higher than the theta c angle. The light is not coming out through the medium, or not, it is not coming out through the medium, but instead of the coming out, the light is reflecting inside the same medium. I mean, suppose this is glass, the light is falling here, and it is not refracting. I mean, it is not reflecting, means it will coming out, but in place of the refracting, the light is coming again into the glass material because the theta c, it is the incident angle is very very high than the critical angle. This is called internal reflection. Okay, this is called internal reflection. So internal reflections is very very important. So how the electromagnetic wave or cable or you can optical fiber work on the principle of the internal reflection. Okay, internal reflections there, the light wave propagations is like the reflection, internal reflections, it will be internal reflections, and the signal will transfer from one portion, one end to another end, like signal. Okay, you can know that the cable. Okay, the this is called the signal will transfer from one place to another place, or fiber optics. Okay, for the internet fiber optics. Okay, this will work on the internal reflections working principle. Okay, next, see the things. This is one light I am falling on a, this is not prism but this is triangular shape. Okay, I am falling, the light is falling on this shape, and the light is bending, and light is falling here, and it is coming out, the light is coming out in these directions. It is acceptable because the light is passing through different medium of different density medium, so the bending of light is there, so bending of light is occurring here. But the interesting thing, when another triangular shape type things will attach to the first one, this is the first one and this is the second one, if we add together it will looks like this one. Okay, and in that case when I will fall one light, laser light, to that object, the light will not reflected, the light will go straight, the light is going straight. What is this? This is the effect of evanescent field. This is the effect of evanescent field. This means that there are non-propagating electromagnetic waves. Non-propagating electromagnetic waves. What is happening when I am adding these two things? In between non there are non-propagating electromagnetic waves. Okay, due to the presence of the non-propagating electromagnetic waves, it will not, non-propagating electromagnetic waves, the light will go straight. Okay, when there is no non-propagating unit, the light will bend in this way. You can study these things through the internet or through the YouTube channel. It is interesting experiment is there. Okay, or you can do it from yourself also. Next questions. Question number 7. Question number 7 is hydrogen is suitable for CI engine because hydrogen is not suitable for CI engine, compression ignition engine or diesel engine, because what is the reason?
High auto
Hydrogen has
ignition
high
temperature.
ignition temperature. See,
C, high auto ignition temperature. if I use the hydrogen in the CI engine, what will happen? If hydrogen will be used in CI engine, what
So it
happen?
will not burn. Actually, no energy will generate, and engine will not run basically.
Exactly. The engine will not burn. I mean, fuel will not burn, and it will not run. Um, exactly, because it is not getting that limit of temperature. I mean, 500 degree centigrade temperature. When the it will reach 500 degree centigrade, then it is okay. So what
Yes,
will
yes.
happen? So unburned fuel will coming out. Unburned fuel. Okay. Sometimes the questions will come. Sometimes the questions came actually. Unburned fuel will, suppose I am asking you that if the hydrogen is used in the CI engine, then what will happen? The engine will move faster. The unburned fuel will coming. The knocking will be there. Something different things. So you have to say that the unburned fuel will coming out. I mean, there is no burning of the fuel. Simple thing. Uh, question number question number or you can or the questions may be asked that if I use hydrogen, a little amount of the hydrogen with the mixture of the diesel, then what will happen? So there are, so what will happen? So
Knocking.
unburned fuel will coming out. Unburned
Okay.
fuel, what the hydrogen will, hydrogen, the unburned hydrogen fuel will come. Okay, but the diesel will be burned, but the hydrogen will not be burned. But sometime hydrogen will also burn because the temperature will reach 1000 degrees centigrade. But more amount of the hydrogen if we put the CI engine, then unburned hydrogen will coming out. Question number 8: in which fuel based engine the knocking is higher?
Hydrogen.
It is hydrogen. Hydrogen powered.
Hydrogen
Hydrogen.
powered
Hydrogen powered.
Because why?
because of high diffusivity,
High flammability.
Yes.
flammability. Sorry, not
Ha,
diffusivity.
exactly. High flammability. Why high flammability? Because it has high diffusivity. Okay. And why high flammability? Because its thermal conductivity is very high. These are all the correlated. Okay.
Basically, flame propagation will not be proper.
Hmm.
Okay, so instead of flame propagation from,
Now, flame
uh,
propagation propan.
yeah,
Uh,
not be, I mean, haphazardly it might happen. So there
That is
will
because of
be,
high diffusivity.
yes,
Flame propagation will not happen proper.
No. Propagations will be very faster. The flame propagations will be very faster, and it will in the combustion chamber. What will happen? Just I have to draw. Just pen is not working. In the combustion chamber, what happen? The flame will quickly propagated, and your wheel. I mean RPM. I mean piston speed RPM. RPM is suppose 500 RPM. Okay. Suppose 500 RPM, in the 500 RPM, 500 RPM means that the 500 revolutions per minute. Okay, 1 minute 500 RPM revolutions. So for each two revolutions, the one cycle, one hydrogen, one combustion should be there. Okay, but in two revolutions, there are before the revolution came, in 1 minute, the before the revolutions came, the flame is pre pre
pre-burn.
pre-burn. Pre-burn. The pre-burning of the fuel, it will hamper the cycle of the engine. So it is not desirable, it is not at all desirable that the pre-burning of the fuel or the flame propagation. Sometimes what happen that at what time the combustion needed, at that time the combustion is not happening, a late combustion is happening or pre-combustion is happening. Okay, for exact combustion, for the exact time there should be the combustion. At very exact time the combustions. I mean, suppose fuel intake, fuel intake, after the fuel intake there will be the combustions. The combustions will release some high pressure, high temperature gases, and this is the expansions will occur. After the expansions, after the expansion, then again the again the first expansions, and after the expansions it will release the gases, and it will again the coming the first step of the intake of the fuel. Okay, for every steps there has a some sequence, but the if the flame propagation is higher, okay, the flame will propagated, early flame propagations will be there, it will hamper the engine, or it will affect the bad effect the engine. Okay, the next questions, question number 9. Question number 9. Which form of energy conversion take place in the fuel cell? This is very, very simple. This is the chemical energy to electrical energy. Question number, answer number B. And ideal efficiency of the fuel cell is given by which of the following expression?
D.
This is the D.
Gives free energy divided by the heat energy. I
Heat
mean the
energy.
enthalpy.
Gives free energy means, do you remember what is gives free energy? In what type of energy we consider the gives free energy? And this is heat energy, you already told.
Electrical energy gives free energy.
Exactly. Gives free energy is considered as an example, this is electrical energy. This is electrical energy. So our output is, for the case of the fuel cell, our output is the electrical energy. Okay. Whatever the chemical energy is converting into the electrical energy. Chemical energy means heat energy. Okay. So out electrical energy divided by the chemical energy or heat energy. So our definition is the chemical electrical energy delta G gives free energy divided by delta is heat energy.
Means the output by input.
Exactly.
Output energy divided by input energy.
Efficiency means that the output energy output divided by input.
Yes.
Okay. This is all about the live tutorial classes of week 11.
So when you are uploading this on the system, or are you sending us this as PDF?
Yeah, every day I have said I am sending the PDF into that link, in which link you are accessing, you have access. Or
Okay.
if you tell that, I will send through WhatsApp also.
Yeah,
Okay.
it will be good if you can send through WhatsApp also.
I think whatever the link you have, you are allowed to access. In that link, all the PDF is there in the sequential form from the starting week of week number 1 to week number 11.
Okay.
It is in the PDF form, you can see, and all the slide of ma'am's Professor Pratibha ma'am, all the slide I have accumulated together and one by one listed. I have one by one. You can go through in the letter also. Okay.
Yes.
Yeah, you can download and save the PDF, and you can study this PDF before exam also. Okay.
Yes,
Before
yes,
the
sure.
exam, it is not possible to go through the video lecture. You can go through the slide of the, I mean, PPT slide. Okay.
Okay, thank you.
Okay. Thank you. Thanks for listening.
Thank you.
Thank you.
Thank you.
Thank you so much.